Всем привет! Из главной студии я, Паша Винкельштейн.
А я Андрей Когунь. И это теперь полностью наша главная студия на конференции Джокер 2021. Здесь мы будем проводить всякие разные дискуссии, интервью, другие балдательные активности. В частности, совсем скоро нас ждет доклад от Себастьяна Дашнера «Building Application with Neo4j and Quarkus». Hey, Sebastian.
Hey, привет.
Привет, Себастьян.
Привет, привет.
I'm doing really well. I'm very excited to be back here from live in the studio from St. Petersburg, so streaming live this time.
What do you think about cameras watching at you?
It's amazing. Like just this whole setup is really. I hope the attendees would see this. It's like you have multiple cameras here. You have I don't know how many screens and computers. It's crazy. I'm really looking forward.
Is it your first time at studio?
No, it's not the first time, but it's the first time being here and streaming myself. So this is really exciting.
Streaming is something like popular these days, right? Do you stream actually anything?
Yes, I do. So I do a lot of stuff like videos and mostly on YouTube, and I also did some live YouTube streaming. So that's also quite fun. But it's a very different experience to just use one camera and then hit start in YouTube, or to have like literally a studio and a lot of people who do this amazing work, so that it works well. So this is really impressive.
Absolutely. Did you try Twitch, by the way?
Yes, I did try this too. I got just more views on YouTube at that time. But I would say it's more similar to YouTube, because then...
Yeah, of course. But, YouTube is about watching something again, and Twitch is a real-time experience.
Yes.
So you say that you have smaller audience in Twitch than in YouTube?
At this time, yes, but it might be just because I build up the YouTube audience over time, and for me it works a little bit better to have these like prepared videos that are nicer to watch, and you can watch it again on YouTube. For me, for code, it makes more sense. Live streaming is more like you watch somebody and you watch the whole journey if it takes time, but it's much more efficient to watch a produced video and stuff like this.
I think that maybe we are not streaming right now. Well, we are streaming, kind of streaming right now. Well, let's try to stream your talk, I think.
Yes, that's definitely going to be streaming and from a nice studio.
And you're on air. Welcome.
Yes, thank you. So, hi again, and I'm really happy to be here now in person, live from St. Petersburg. And today we're going to see how to build applications with Neo4j and Quarkus. And I don't have that many slides because I'm more a live coding fan. So this is actually the only slide that I have, my name and some information about myself. But other than that, I actually want to use the whole time to do live coding. Yay, because that's more interesting, right? And of course, everything can go wrong, so it's not recorded. Actually, if I make some mistakes, you will see it. Yes, about these applications with Neo4j and Quarkus. So probably you have heard about this Quarkus technology, which is therefore building modern enterprise Java applications. And Neo4j is a graph database. And I want to focus a little bit more on this because most enterprise developers know about relational databases and know about some certain frameworks. And I want to focus more on the graph database side today. So what we have, well, we can have a look at the website, Neo4j graph database. This is probably the most popular graph database, especially in the Java world. And this is, offers a really nice experience, I would say. And what we're going to build live today is coffee. Because, lubię coffee. I like coffee a lot. And this is why I like to have these type of examples. And today what I would like to have is a little bit more advanced data scenario where we have certain, coffee with a flavor. So if I can introduce you to this coffee world, it's like, it's not just coffee, it's tasty or not tasty, but coffee has a very rich, experience in flavor. There's actually a fun fact, coffee is more rich in flavor variety than wine. So if you like wine for its different varieties and certain directions of the flavor, coffee offers even more. But what I want to show you first is this model of our domain. And I think the best way to show you this is actually, well, in a graph database directly. Because Neo4j, and I'm just starting this up right now, it offers a nice explorer in the browser, where similar to your database explorer, you can just see what it looks like, but it's very, very graphical. We will see this in a second. And then, of course, I will show you how to map this to our application. So today, and you will see this, well, this is a Maven project with Quarkus, so I do a lot of coding with that. This is just called favorite coffee, because we're gonna rate some coffee based on some certain flavors. I think that's interesting. And then that means we have a Quarkus application here. So this is just like a Quarkus application in the recent version. And I'm gonna show this in a second. So now that's just the log of my database. It started up. And then localhost, I can check the database Neo4j browser, standard port 7474. And the nice thing is, I'll make this a little bit bigger in a second, we have an explorer where we just see some nodes. So probably it's very small to read, but it doesn't matter. You just see, well, 4 dots, right, like in a blue color. And these are entities, like nodes in our graph. And the interesting thing about the graph is actually the relation, so that we can draw some arrows in between. And what this means now here is that actually we have a certain, well, coffee bean that, well, tastes like something. And the taste you will see here in the brown dots. I can read it to you. This is just some Spanish made-up name. It's called El Gato Loco. That is the name of the coffee bean. And these are just flavors. So what does this mean? If you go to a nicer coffee shop, and one thing I like about St. Petersburg, they're really, really good coffee shops where you can get really nice specialty coffee. So for a better coffee shop, you not just say, well, give me one coffee. You can usually choose. So they tell you, well, this coffee is actually from Colombia. It grew up in this particular height and whatnot. And it tastes like a certain direction. And it's not just, you know, tasty or not tasty. It is about, well, does it taste floral or like fruits, like berries maybe? Or does it more taste like earth or nuts and chocolate? So there are many, many varieties. And there's a so-called coffee flavor wheel with certain, I don't know, maybe a dozen flavors. And you can say, well, it tastes like certain multiple flavors. So here, this, for example, it's called floral taste and a fruity taste. And here you see it in, just look at the colors here in the graph. You see this bean, it tastes like something like a floral taste and also like a fruity taste. And these relations, they're literally like an arrow that you can draw. They can also have some properties. So for example, I can show this right here. These, I can show the percentage. For example, you can say, well, 70% it tastes like fruity taste and 30% it tastes like floral, right? So you get a spectrum of how much these coffee beans taste. And also the red dot on the left, let's just focus on these 4. The red dot on the left is a country. So here it says Colombia. So this coffee bean is from Colombia. And that's basically the data model I want to have a look at. So why do you think, well, that might be interesting? Well, if we have certain queries later on in our application, and that's also the big question, when does it actually make sense to use a graph database, where we have some more advanced queries, then it is a really nice way to store and retrieve your data. Why? Because in a relational database, you probably know about these join tables. So if you say, well, I would like to query some certain data, and then you have a lot of joins, like, you know, join this table from the other table, and then it is a lot of effort, and also performance-wise, it might become a problem. So this is this depends on, you know, how your data, how much you relate your data there, but it might be a little bit more, well, effective or actually better for performance to do it in a graph database. So in this way, let's have a look at the code and how this is related here, because ultimately, I would like to store this in Java types. I would like to map it similar to what you can do with JPA or some other framework in Java. And now what I would like to do is to show you, then you probably fully understand this domain model, to show you the coffee bean. So if you're familiar, now we are live, so I cannot do any polls with raising hands. Who knows JPA? Well, probably a lot of you, right? So if you've used Spring or Java Enterprise, you probably know about how to map these into Java classes. And with JPA, we had @entity, right? And this is now at node entity, which is very, very similar. So we have a class coffee bean. So this represents a coffee bean. And we can then have something like an ID. This is the same name like in JPA. We can have certain other properties here. And we have at relationship, which is very similar to having some other mapping tables or mapping columns. So this means, well, actually in Java, it makes much more sense if you think about it from your Java objects. A Java object in the heap is already a graph, right? So you have your Java objects with the references who pointing to somewhere. And this makes much more sense to actually use a graph database in this regard, right? So the coffee bean just points to what is called an origin, like a country. And this is just another class. And you see, well, that's just a reference in Java. And in the graph database, it's also a reference. It's a relationship that has a name. It's called isFrom, right? So your coffee bean is from a country. So it reads naturally. And also you can have multiple of these. So flavor profile means, well, you have a coffee bean that tastes like specific flavors, and they all have a certain percentage. And how this works in the mapping here is that you say that is an entity that represents kind of the arrow in the graph. So it said it had a certain percentage. So here you say, well, how much does it taste like that flavor? So that's basically how you can map these. And you can have an access to the start node and the end node. So in Java, these references themselves cannot have properties. So this is why we need this helper entity in between, this relationship entity. And then we can have some other ones like flavor with some specific name and so on and so forth. But I think you get the idea. So this is basically how you can map these objects into your Java application. That is called Neo4j OGM. So this is very similar to JPA, and this is what we can use. And now what I would like to show you is a little bit more of live coding, because what is really cool about this Quarkus technology is that if I use Quarkus, I have access to this live coding, Quarkus Dev. Quarkus Dev is actually a Maven plugin that knows about your source code and makes it very, very efficient and fast to make changes in your application. So you don't have to wait. Well, the first time, now I'm talking the first time you have to wait, but then between restarts, you actually don't have to wait. You just can start the application first, and then you can change your code, and you will see the changes immediately being there. Okay, let's try this out. So first, well, what do I have? Localhost 8080, so this is my application. And then I see, okay, it already has some HTML output, so great, this works. But now what I would like to do, I would like to live code. How do we get access to these coffee beans, right? So that you see how this works. And for that, I write a JAX-REST endpoint, like a REST endpoint. If you know about Java Enterprise, this is just a JAX-REST boundary. If you come from the Spring world, then, well, this is like a Spring REST controller, right? So I can call this, let's call this beans resource. And this can be some coffee beans here. Okay, so let's have a look at this. It should be something like a path beans, and then some maybe an application scope bean, and we say this produces some JSON. So I want to go there and then just return some, well, coffee beans. So I can say, well, not a string, but let's say list of coffee beans, get beans. This should be returned, right? And then I can call this method and then, for example, invoke something from coffee beans. Let's say we want to create another class where then we can output this, right? So this would be very similar to more traditional relational database. What we would do in a relational database with a JPA example, let me just finish coffee beans, list all beans or something like this. I just basically create a method that loads these beans from the database. So now what we would do in JPA, right, like have either something like an entity manager here or like a Spring Data repository or like a Quarkus Panache repository and list all the data here. What we can do in Neo4j OGM. So in OGM, and I will go to this Quarkus support in a second, so we can have a look at the website here. There is some support for Neo4j in Quarkus already, but fair enough, it's still a little bit, well, a little bit early, in the early stage. What it does, it configures the driver for you. So this is not bad. It at least configures the driver, but it's not that much fully fledged like in OGM, what you would know from using JPA or actually using Spring together with Neo4j OGM. But at least you can have these, well, you can read for that page. You can have these configurations out of the box, and then using the properties, you can configure how your database access looks like. Okay, and then we can use some CDI feature to access this, which is called session factory. So ultimately, to access it, we need a session factory. And then you can do a thing like return new session factory and create this. Well, but we are lazy. We don't want to do this ourselves. So we write this class once. That's a CDI producer, application scope producer. And then we say, well, please produce one once we @inject it, right? So basically we say, where's my coffee beans? We say, please @inject my session factory. Session factory from OGM. There are multiple ones, but we want the one from OGM. Why? Because then we can use this to load our coffee. So then we can say session factory, please open a new session. And then we can use this, and this is now very similar to, well, JPA or any other of these frameworks. So we can say, please load all the coffee beans. Okay, coffee beans.class, and that should give us, I think it's a collection, so can just say, please put this into array list or something like this for now. And then we can return this here. What's that? I think that's just IntelliJ complaining. Cannot infer arguments. Of course, you can infer the arguments. That's super easy. Okay, let's have a look if this works. So with the dev mode, what I said before, it just quickly reloads this whole application. And then I can actually go, okay, maybe I didn't, has incompatible bounds. Okay. You see, this is all like live. I did something wrong and I didn't even see it. Coffee beans. Oh, yeah, that's it. Nobody told me because, yeah, I know people cannot scream at me when they're watching live. Probably everybody saw it and said, oh, Sebastian is so stupid. He misspelled the class. It's coffee beans, singular, right? So now it works because that's a different type. Of course, we want to load the entity type here, right? So we load all these coffee beans. That's just a default method that we can invoke. And now I want to, not this one, I want to have the curl command again. And now I can see whether this works now. Okay, I want to go to localhost beans. And then, okay, great. Now I get a response. I can pretty print this in JSON and it already lists all of these beans. Okay, interesting. And what it also does, because in Quarkus this works out of the box, that I say, please output this to JSON, and then it shows the whole object hierarchy. So it has some flavor profiles and it has a name and origin and whatnot. Let me just like list the name here by saying JQ, please give me the name of all of them. And then we see it right here. Okay, so that's just a very basic example of listing all of these entities, and then we can work with them. What we can also do is then have a little bit more sophisticated things. So we can say, well, please give me the sort order and sort them, let's say, by name, for example. And then we can do the same thing. It will quickly reload. So again, this is really the nice thing about Quarkus in its development mode. It's super fast. You know, I can try out things. It fails. I try it again. I try it again. And here now this is sorted, and so on and so forth. So this is just an example how to get this here. How can I run some queries? Well, this works as well, and with queries it's actually more interesting, because I think the nicest use cases in Neo4j is not just say load all the coffee beans, because you can do this in a relational database as well, but having some more complex queries, for which we will see a few a little bit later. But for that, let me go back to the actually to the browser, and 1 second. I now open up my Vim environment because I'm more of a Vim person than in the browser. So if I say, well, I would like to write just a very basic query, please match all the coffee beans, right? And say, oh, please return this coffee bean here. And then I can go in the browser and just execute this. So I say, well, please match all the coffee beans. That's basically what we had before. So that's not that interesting. But now if I would say, well, please match some coffee beans that taste like a particular flavor, right? So for example, I really like something like a fruity flavor, right? So I think the name is tastes. Something where we have a flavor, I can match this here directly, where I say, I think it's the name fruit. If I make a mistake, then it will tell me immediately. And then I get 2 back. So what does this do? This is basically a match. So I say, well, please match for the structure. You see, this is almost a little bit like ASCII art. I can draw an arrow here and I say, this is basically one node. The first thing here, this is one node in the graph. And this here is basically the arrow. So I say, okay, please denote which points to flavor. So it's kind of like saying in SQL language, select all where there is, some specific property. Or here it would already be more complex because you would need to join to another table and then see, okay, where the property of the table of the other table is as follows. I can also write this in a different way and say, match the flavor where a flavor f.name equals the fruit, and so on and so forth. So that works as well. And with here, I can match these criteria. Okay, so that's the first thing that I can do. Then I can have a little bit more specific things. So now I only have 2 beans available, or 2 flavors available. And now what I want to do, just to make this a little bit quicker, is to show you a little bit some more code, so that we can have some more advanced queries. So let me roll out some other stuff that I did. Restore stage, something like this. Just want to undo my changes. What was it? Git clean, I think. And that should be it. And yes. Because now I can show you what I prepared before. Because if I have a look at the coffee beans, then I can say, well, for example, give me the coffee beans with some specific flavor. And now that is something like what I showed you in the command line, but how does this work into my Quarkus application? Well, now it gets a little bit interesting. We say, well, the session can also do some querying, very much like in any relational database as well. But now I can say, here you see some cool Java language features. I'm using text block for that. That really makes sense. Now I can say, well, use a specific coffee bean that tastes like a specific flavor. And of course, you can provide this with some extra parameters and say, okay, please map the flavor into this. How do we use this method? Well, also from our coffee beans resource. So I can say, well, if I provide, I think a query parameter makes sense for this one. So if I say curl localhost beans, and then I say, well, beans flavor, I think it is, equals fruit or something like this. If I made everything correctly, now it of course will restart because I changed the code, and now it will give me, I think these are 2 coffee beans, the same that I got in the browser. So this works as well. I basically say, well, query everything with a particular flavor, and this is already a query that matches multiple things. Okay, now you might ask, where do the other lines of code come from? So we have match the coffee bean here, but also match something else is from country and tastes like flavor. Why? Well, actually, this is required in order to populate all of the information here. What would happen if I don't match and return them? Well, we can try this out. So I could say, well, this doesn't work. We could say, well, just leave away the country, or do something like this. Let me just save this for later. If I say I don't provide all of these information, I don't return these, I only return maybe the coffee bean, what would change here then is that the information later on would not be populated with all of the fields. So did you see the difference? Now it actually returns only, well, the information of that particular table or of that particular type. In relational databases, that would be just one table without all of the joins, and the object is kind of like empty. So all the other relations in that object are then not filled. Okay, what is this type of magic? This magic comes actually from Neo4j OGM and automatically maps all of the data that we have available. Let me scroll here. That are returned in the return statement. So from that return statement, we see everything here is included in the query, it will be returned. And if it's returned there, it will automatically be matched. Okay, so let me just explain this one more time. I show this in the browser. Flavor is, let's say, fruit. And with this, I now fire this query. And if I have a look at the table result, it might be a little bit small, but you see there are multiple columns here. And all of these just are sets that are returned for the same single row in the result. So all of that is just like 2 rows. And the right ones here are 2 individual data, like collect is from, country, tastes, so individual data for the nodes and the relationships. And once that is present, OGM, Neo4j OGM automatically maps them into your objects and populates these fields, and then that's available, which I think is very, very nice, because then that just makes it easier for us. Initially, that query is a little bit more complicated, but then once we return this, we can just say, well, please return, for example, a list of coffee beans here, and then we can return that to the user. So that is another way to have a little bit more interesting queries. And we go through a lot of them now until the end of that talk. So that's, I think, just a cool way to look at graph databases, especially once we have this more complex querying where it really makes sense to have a look at these use cases. So for now, it says, well, match a particular coffee bean that tastes like a particular flavor. So that is one thing. And then what we can also think of is basically a more sophisticated example where we have more data available, or where we actually say, well, what does a coffee bean taste like? And based on that information, what else might we like, right? So when we talk about recommendations, I think now this is an interesting topic. When you browse something on Amazon or some online shopping site and you see other users also bought, right? Or based on your preferences, you might like these articles as well. And I think that's a very interesting thing to think about from 2 aspects. First of all, from the data engineering perspective, like what can you technically do to provide all of these data in an interesting form? And secondly, from that aspect, to think about your domain and say, okay, what is the interesting criteria here? What does it mean that if I like that particular coffee bean, I might also like the other one? For example, for this reason, this application comes with another view, like we have some very basic view available here. This is just a list, but later on it will be longer, where I say these are the coffee beans in our coffee shop available, and it tastes like a particular taste profile. And then I can rate. So that's just a thing that I will show you a little bit more of. So we say, okay, you go to the coffee shop the first time and you have no idea what you want to take, so you just pick a random one, and then you try your coffee and say, okay, do I like this or not, right? And based on that, it says, okay, if you like the coffee, what does that mean? Well, maybe you like a particular flavor profile, maybe you like some fruity coffee, or maybe some sweet and caramel chocolate tasty coffee or something like this. So then you basically can create a user profile, like a profile of what your preferences are, and then in the future you can match on this. So that's the idea. And then it really depends on your domain what these criteria are that you would like to take. So for example, you say, well, I would like to have the taste profile to take these as the criteria what I like or not. Okay, so in this way, let's have a look at some other examples. I use my database run script. This is, well, just how I start up my database. I basically say a sophisticated Docker run, but I say, well, I can also just add some scripts via the Cypher shell. So let me just execute this directly. Cypher shell. It's not example data. It's coffee. I think full coffee example, something load coffee data. Because what I did, I actually wrote a web crawler because, well, I could not think of Cypher. Yes, I could not think of so many examples. The 4 beans that you have just seen were just out of my imagination, so I imagined the name. But then basically what I did, I went to a coffee producing website, like where they sell many coffee beans, and I wrote a Selenium and Selenized-based crawler to get all the data to just build a better example. And the outcome was this one, that I say, okay, I have almost 100 coffee beans, where you have, you can go through that list where you have a particular flavor, just to have a better, rating experience. Okay, and now what I would like to do is to say, okay, now I need to try some coffee, right? That's the nice part of it. We go and say, okay, let me try some coffee and see what it tastes like. Some fruity taste, so, maybe that's a good one. So assuming you try some several coffee and say, well, where is a good example? Let's say this one here was very nice. So I give it a 3-star rating. So I just, click on 3 stars, and you do this with a few. You say, oh, this was also very nice. And what else do we have? I typically I'm not a big fan of some, chocolatey or earthy one. Let's do this a 1-star rating. Maybe some other 3-star rating. Something like that, right? So I just go through the list. This is a coffee shop that offers a lot of coffee, and I try some. Okay. And now what I can do, let's say I can sort these with a different type of criteria. So assuming I say, okay, now I know what I rated. These are just all of them sorted by name, and maybe I want to sort them by rating. Okay, that's an easy operation. I just have the view, and what does it use internally is it follows that also it uses this coffee beans, and it says give me the coffee beans with particular sort criteria. And sorting by name is kind of easy. We just did this in the very beginning. We say, well, please give us all the coffee beans sorted by name. But now sorted by rating is a little bit different, because now we need to already match a little bit. We basically say, well, match all of this data, including the origin, what we have, flavor, and all of it. And then at the end, we'll return all of it and say order by the rating. And the rating is, well, everything here from the user rating. So what we now introduced is a new type, user, and the user can rate a bean. Okay, let's have a look at this. User, of course, is also a node entity. So assuming this is a multi-user application, but for now, for easier purposes, you are the only user in the system. And then you say, okay, I rated a particular, bean. So I say the user rating is again one of these arrows. So I can say, well, please just rate some particular coffee bean. And then there's a rating, and this really depends now what you want to model. Like in YouTube rating before we had, I think, like 5-star, and now it's only like or dislike on some criteria. So now I say rating here should be an integer of 3, right? Like 1 star is very bad, 2 stars kind of like whatever, and 3 stars is really good, right? And this you can take later on for your criteria, what you actually want to select and what you would like to compose with. Okay, but the easy thing is you just have a user, has a unique username, and you can rate some coffee. How does this look in our browser? Let's have a look here at the graph. We see, for example, let's go back here, we have some user, and the user has a specific, way to rate some coffee. So say, okay, the user rated these coffee beans already and some other coffee beans. It's somewhat big enough to read that. So basically, we rated 4 coffees already, and they have particular different ratings. For instance, 1, 2, 3. And then we see what is going on here. Okay, so that's the easy part. But now how to use this data. This is more interesting. So in our application, we can see index controller used this coffee beans, yes. Sort by rating now used this particular one. Okay. What is more interesting even is sort by recommendation. Now, well, that's going a little bit more into this particular example of data science or of using this information to make something sophisticated. And usually this is a little, I would say even a little bit different than some other parts of being an enterprise developer, because usually what we do is very straightforward, right? There's like one particular solution and you say, okay, please load the information from the database and either it's correct or not, right? But with such an example, it's more nuanced. You can try things out. You can say, okay, please sort by recommendation, like recommend something based on, well, a particular flavor. And then maybe some flavor might be more popular than another flavor. So what you do here, right? So this is quite interesting already. And then we can, for example, sort this in that way, where then by hitting the recommendation, we see, okay, please, 1 second, sort this by some recommended coffees. So now we see, okay, the ones that we rated the 3-star rating are, of course, pretty much at the top. And then there is some particular profile that we see. And if I scroll all the way to the bottom, then at one point we see the 1-star rating that is, not really recommended because, well, you gave it a 1 star. But also if you have a read through all of these flavor descriptions, they are pretty similar. For example, you say, okay, this one that we rated 3 stars has a flowery taste. Okay, and here you see flowery quite a lot, right? Or this one has a fruity taste and also fruity. So you see there's a certain pattern where it already matches, okay, what you tried, you get really similar recommendations. And the same way, if we scroll down and if we say, okay, the 1-star rating has some chocolate, earthy, okay, we read earthy, chocolatey, and so on and so forth. So this also has a particular flavor. So that is already matching the idea of saying, okay, you like this particular product, how about the other ones? And this is what now in that part I want to, well, place a little bit more importance on, and especially how to look at some more queries, and then also more about the Quarkus implementation, the application and how to implement this there. But I think now we have some announcement to make as well. So this you will actually see in the second part, and you have to be a little bit patient. And until that, so now more stuff on graph databases. And now in the first part, what did we already see? We saw how to use Quarkus with Neo4j, so how to make that initial connection. And we also saw how to make some basic queries, right? Like how to, for example, store some things in the graph database and how to retrieve them. And now what I told you about these recommendations, I want to have a closer look into this. And basically what we have, or what we can come up with, is such a huge query, right? Like, oh yeah, that's hardcore what we had before. So how to get there? I mean, first of all, I will just read this to you and try to explain what makes sense here, and then we will see how do we get to such a query, like what is a way to try this out yourself and to just engineer this into that rating or recommendation perspective. So what we do, well, first of all, we would like to get an idea which flavor does a particular user like. So first of all, a user rated some specific beans, but the beans have flavors. And what we're interested in is to use the flavor as the criteria to match something close or like. And for that, we first of all match all the flavors that we have available and say, okay, as an optional match, which of these flavors actually were rated? Okay, so, and then we can think of something, that is a weird expression here, this coalesce, what does it do? It basically says, okay, use the rating, or if it's not available, use 2. Why 2? Well, because 2 is actually in the middle. You can say, okay, if it's 1, it basically is a negative, right? You didn't like the coffee. If it's 2, it's kind of like, so-so, and if it's 3, you really liked it. So assuming that 2 is kind of like in the middle and you want to even it out, so let's say that's kind of in the middle, so 2 and then minus 2 gives us actually something that is either plus or negative. So then it's in the middle is 0, that's okay, plus 1 is really good, minus 1 is bad. Because with this we can use it in order to make a product out of it, to say a rating times a percentage or something like this. And then we also want to see, okay, if a flavor tastes like something, we want to include that percentage in. Why? Well, because if you say, for example, your coffee tastes like fruit for 70%, this is stronger than fruit for 30%. So if you rate that down or up, it should be taken stronger than if it were only a small percentage. And with that, we say, okay, please, with use this percentage and this rating, positive or negative, to calculate usually something like a weight. And with this weight, you can further select or, of course, then order. So for this particular, say, okay, match then all the coffee beans that tastes like these are still all the flavors. So why is this done? Well, to get the coffee bean then in the second run. So this is kind of like two parts of this query and the second query. And then do the same thing what we had. Please match all the other data that we can use it later. And then return all of these data here. That's easy. And then use this weight, what we had, to order it by this weight. So the first weight is the weight of a particular flavor, and then ultimately this weight is the weight of the whole coffee bean, right? Because the coffee bean has a spectrum of multiple flavors, and all of them have individual weights, right? So if you think about it, okay, then we can order by this weight as well, and that gives us a rating or an order of all the coffee beans available. So I think this is quite interesting. And now you might say, okay, Sebastian, this is too hardcore, or this I cannot do this myself. How do you get to such a query? Well, I can tell you at midnight, I woke up and I had an insight and wrote this query. No, I didn't, of course not. So how do we get there? What is quite helpful, in IntelliJ, we can have a connection with Neo4j, of course, and then we can say, okay, please, match something. So we can have very basic recommendations, and I think this is kind of similar, the ranking of all beans. So we can go and say, well, please execute this against my database, for example. And then we can set this up with the connection, if it is there. I hope it is. But basically, yeah, no query selected. I think that should be it to run. Oh yeah, localhost, yeah. And then you will have the results, which are now very big. So graph doesn't really make sense, but table makes sense. So with the table, we see, okay, now this is of course too small to read for you, but it's also 100 entries. So basically you have, well, some beans available, the same that here you see in this list. And then what I would advise to say, okay, let's have a look at these results and whether it makes sense. But that didn't answer my question how to get there. So this is just how to execute this in IntelliJ. But basically what I would do first is to do this individually. So you see we have multiple matches here. Match, 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 match. And all of that is a subquery. So match all flavors, okay, that's easy. So you can use this and say match all flavors, return flavor, and then execute this already, which gives you all the flavors. And then in the next step, so you see I do this step by step. I say, okay, please give me all of the ratings here that we have, and use this, and then say, okay, return. Now, what we have here, return the rating and the percentage flavor. Okay, that's not quite interesting yet. But if I say now, please calculate the flavor weight, that is more interesting. So if I now say, okay, now use this and return just the flavor and the flavor weight, return this here, and then run this in, I think somewhere here. How does this, did they change this? In IntelliJ, that's interesting. I could run it with Control-Enter, but now I can't. Okay, now let's run this particular query, and then it should give us that particular thing. Okay, let's try again. Run it in localhost here, and now it gives you a flavor. Okay, this is a little bit too small because of my font size. Let's run it here directly. That of course also works. You can say ranking of all beans, and then it gives you a particular table with a flavor: buttery, chocolatey, nutty, fruity. Fruity. Spicy is negative. Okay, and flowery is positive, right? So you remember fruity, flowery. This was really good rated, and now we have all the flavors and the weight, right? And now I can say, let's stay here. If I want to return them, I can already order them, right? That's what I want to do later. Order by, hello, or, okay, why can I not tap? Okay, something is wrong with my browser. I think it's just maybe, that's interesting. It doesn't let me type. Okay, maybe I cannot type here, then I type there. I have multiple editors available. Order by, flavor weight, right? So I can use this and then enter this here. and say, okay, now this is a chocolatey flavor, earthy flavor, that's all negative. So later on, it's kind of like rated down. You dislike the flavors. And now we go into the positive space just by the flavor weight. Fruity, yes, that was a nice one. Flowery, very good. And then you see, okay, how to rank these, right? So in all of these instances, you kind of think of the underlying criteria, right? You're trying to break it down. What did you actually like about a coffee bean if you press like? Or what did a user might like about it? Well, it might, you could break it down into its individual components. It consists of certain flavors. And you maybe see, okay, it really liked this flavor. And then you see how much does it taste like this flavor. And you can rank it based on some specific weight. So that is a particular use case here. And then we can continue further. Okay, if this is now the case, right, so that was still manageable. I just have these 4 lines of code. And I write them, one after another, basically. And then say, okay, use this flavor weight now where it makes sense. So first of all, I want to go to this result and really check with the data that I test, does this make sense, right? Does it make sense that this particular flavored chocolatey is rated down and the other one up? If yes, I think this does make sense because we rated the coffee accordingly. Then we can continue and say, now go to the coffee beans and match this by the flavor. And the rest is then just saying, okay, further accumulate the weight with the individual tastes like of the coffee bean. Because the coffee bean, again, has the spectrum, and then we just take, well, the sum of it. If that makes sense, well, we can try it out, and then return it. And if you come up with this query, then you basically end up where we have the result here in our browser, where we can say, okay, please reload this by the recommendation, where now this tastes like a particular thing. That's the sum of all of these individual weights that we just collected. Okay, works. That is one thing about one particular query. If you think about it, how would you do this in a relational database? Well, then you're already into a little bit more complex sphere. So this would be more complex to have this in a relational database. You would have to do a lot of joins, and probably you end up with something like a materialized view or some other criteria here. But if you look into this query, it looks a little bit complicated at first, but actually it's quite concise how you write it, right? It's like just these 2 lines, match all the flavors, and then optionally match all the ratings that a user had to this particular flavor as well. So it's a tuple that you then create, and you can use all of these ratings to a particular flavor. So that's quite, I would say, quite interesting to write this in such a concise way. Okay, so that's one thing. One other thing that I want to show you is some particular other user information, but at first I want to answer the question, how do we even save something, right? Now I only was loading some data, but it's also interesting to say, once a user presses like, so let's say we like this coffee, now you see that, okay, it changed a little bit the schema. I use a different rating now. So now, because all of it is fruity, because I just liked yet another fruity coffee. So it's changed it a little bit. So if I rate yet another coffee and I say, okay, maybe 2-star rating, and then this is saved in the database as well, right? So this is the user-rated coffee relationship. How to store this? Well, basically you can create these objects like a coffee bean and then say session factory, please, well, persist it. Or you say, well, you store this with another query. So we can have a look at, first of all, our checks arrays resource, how to store this here. For example, we'll create another bean, update bean, or let me see, there is some other controller that we use, user, I think it's user page, no, not the user page controller, where we actually like something like this, update bean, rate bean, here we go. And with coffeebeans.rateBean, we say, well, please rate a particular bean that is identified with the rating from 1 to 3. Okay, now what I typically do, and this is now due to the fact that Neo4j OGM is not as advanced as JPA or even the Spring integration. So if you use plain Neo4j OGM, you cannot use something like transactional. So this comes from Java X transactional. This does not work, or it would not do much now. I hope they actually will implement it and Also, I was talking to the Quarkus folks already, so there is some interest in this, but of course it's much more sophisticated. What it now does is, well, you have to run these transactions yourself, which is, okay, there's a little bit of effort to say, okay, session begin transaction and then commit and all of it. What I usually would do in a project is to say, provide one point where you write something like these private methods, or where you have a single point where you manage them, and then use it from a Lambda or from some manageable way to provide a runnable, and then within that you run it so that you don't forget to call commit and catch for exceptions and rollbacks and all of it, so that you have code that handles this only once. And then it's kind of okay, so you say run in transaction, like here, and at first in the transaction you load the coffee bean again, you load the user, you check if they're actually available, you create this entity type, user rating. So this already works if you just set the rating here. So if you say you create this bean, this entity, and then you set the relationship in Java, and once the relationship is set very much like in JPA, you can say, okay, save it, and then it just saves it. What is also interesting with regards to both saving and loading is the depth. So this is a depth of 1 that you say, please save this node and all the other connected nodes with depth of 1. So just like one, like hierarchy. So if you would like to load something with, for example, infinite depth, then you load the whole graph if all of them are connected, for example. So this really depends how much information you need or that you want to change. Okay, and this is then basically how you do this. So all of these methods are available from this OGM object, like session begin transaction. You can have the transaction commit, close, etc., and so on and so forth. So this works with storing. Okay, so then we have this as well. It's same for the beans. You can update the bean and change its flavors and whatever, and that is how you make these changes in Neo4j. I really like this integration here. So for what is available, it's not, if you think about this, it's not perfect yet, but just the fact that this works well, and it works well with Quarkus with the dev mode. So now I was just running so far this dev mode and Quarkus dev, and it also works with the JVM mode in Quarkus, where you just have the production mode, which wasn't the case in the beginning because of class loading issues. But so far, this I think it's a quite nice experience for most Quarkus application, that you can include this a little bit, writing it by yourself, but then you have all of the features of Neo4j OGM available. Okay, and now one more thing about our application, about the user profile. So if I click on this one, then I can go to the profile and I see an overview. This is more like what you would see in your Amazon or when you go online shopping. You see these are the rated coffee beans. These are the ones that you liked or that I liked. And then this is just something based on your preference. Based on my preference, these are coffee beans that I might like, but unless the other view, these are ones that I haven't tried yet. So you say, okay, you drink the same coffee all the time. Wouldn't you like to try something new? And that is just an overview for this based on your preference. So let's have a look at that query as well. So in our, I think it's called user page controller, we get recommended beans. So these are beans similar to what we had before, but doesn't contain the beans that already have been rated. So let's have a look at this code. It's very, very similar what we already know. Please match everything here as well. But also have another where it doesn't exist that the bean has been rated by the user. Now, if you think about relational databases again and how you would do this in SQL, this already might be very complex, right? To join another database and to make a subquery and say where this is empty or not. But here, I think this is almost readable, right? Like where this structure doesn't exist, like where the user didn't rate that particular bean, right? Like make the same things like before with the flavors and the weight and everything, and now match all the coffee beans that taste like a particular flavor, but only the ones where this structure doesn't exist, only the ones that the user hasn't been rated. And now if you read these two lines of code, this is almost readable, this is almost understandable, unlike some other SQL code that might be more complex, and you see where this structure doesn't exist, then please don't match them and all the other ones will be returned. And yes, please return only 10 of them. And that is just what you get here. So that is the overview on that page where you see all the recommendations, but the ones that you haven't tried. And the last statement here, new flavors. Feeling adventurous. These are beans with flavors that you haven't tried before. So if you say, well, this is actually some other flavor, some new flavor, like a new nuance that you haven't tried, so that you didn't rate up, but that you also didn't rate down. Because if you disliked it, then why would you try it again? Because you didn't like it. But there's something that you try again. So when I was a child, my mom always said, well, you always have to like at least try, some food that you think you didn't like. If you don't like it, then it's okay to say no. But if you haven't tried it, then you cannot say no, you don't like it because you don't know. So these are just like new flavors that you haven't tried. And for that, we have another method, get untested coffee beans. So flavors that haven't been rated. And then please give me some beans with these flavors that haven't been actually rated with some other rating. So with that, take the flavors and use basically the rating here. And now I do it a little bit otherwise. I say use the rating and then just if there is a rating, like now rate this down, because we want something that actually we haven't tried, something that is not the usual coffee that we drink all the time. So now take it the other way around. Just basically punish it for being rated before, so that we take this lower. So with a particular coffee bean that tastes like something else, and of course a bean that hasn't been rated directly, so otherwise you would drink the same coffee again, then please return these, right? So now you just change this information, what you select by, a little bit. Okay, and then return this, also 10 of them, and this is just the results that you get there from new flavors. So that is basically what you have there. You can, of course, try this out yourself. So all the code is available, and also these, coffee beans examples. And again, this works with Quarkus in the JVM mode. Now, what about, some other things about Quarkus? Because if you tried it out yourself, Quarkus, you probably have heard about this native mode and building applications that you can compile to a natively executable. Does this work with what I was showing you for Neo4j OGM? No, not yet, because the support is simply not there. Because running something native isn't just a no-brainer. It is not very easy. It's kind of complex to implement this, and it's not there yet for Neo4j OGM. Would it work in theory? Yes, of course, because, there's also JPA in Quarkus, and you can have a Quarkus JPA application that is compiled to a native executable, which is pretty interesting. I don't know how fast it is, so if there's some interest in it, and of course, if somebody would like to contribute, I'm pretty sure the Quarkus folks and Neo4j folks are very happy about that. But what I would see or say about it, so I actually wrote applications that use Quarkus and Neo4j in production, and they all run in the JVM mode. And in general, that's a bigger, different topic about Quarkus in general, but in general, I would say JVM mode makes most sense for almost all the enterprise applications out there, because you code and you run in Java, and usually you don't have that requirement for the fast startup and the extra savings in resource consumption based on the other trade-off that you have to do by building it for a long, long time, right? Because building something natively takes a lot of memory, takes multiple minutes, even on a fast computer, to build it. And usually, from my perspective, it doesn't make sense even for other Quarkus applications where it would be possible to build this to a native executable. So that's just my take on that. And to wrap this up from the code perspective, so that is how you access all of these things. In the properties, we configure the Quarkus application. So in whatever we use there, later on I will give you some more pointers online where you can see how to deploy a Neo4j application, to try it out, to deploy it locally. This example, for example, uses the Docker approach where you just Docker run something locally. This works well, and then you load some examples by Cypher, for example. So this was the first thing what I was showing. You can create all of these things. And what is also interesting, so that is the data CSV file that I'm using. So it supports CSV, and you can just load all kind of data into your database and try it out. If you want to try out Neo4j, I recommend to have a look at this browser first, because it's it supports your queries. It will auto expand them, and you can just click around and you see, okay, now there's a lot. You can just drag and drop them. It's kind of fun to do this. So you can just explore the whole browser here, and you see, so you have a lot of dangling nodes in your browser. And it's much more, how should I say, it's much more visual than your typical relational database. So it's actually, I think, easier to comprehend from that perspective, because you see it in a visual way, and also it matches much more how you map these objects into Java. So what we've seen with the OGM, it is much closer to actual Java code. And then you can run it from there. And the Cypher, I would say, is a nice query language for having some more complex stuff. All right, so with this, you can try out all of that. And just last and important slide on the first link, you actually see all of the examples that I was showing and some more content on that. And yes, first I want to say spasiba and thank you for listening, but I also want to have a chat with our experts. So Pasha and Andrei, what do you think? Do you have some questions about this technology, or what are your views on it, especially on graph databases?
First of all, thank you for your talk. It was very useful, I guess. And пожалуйста. We have a couple of questions in the chat from our attendees. And Artyom need to know where exactly Neo4j is being actively used. Maybe some examples.
Some examples, yes. So everything where you, I would say, are quite heavy on the not only querying side, but where you have some more sophisticated querying usages. So something like some recommendations where you have a more, like I had this variety of spectrum of information, or something where you have data that is highly correlated. Something where if you think in the relational world, you have a lot of joins, a lot of join tables and columns, where this is effort to link all the entities, I would say. So anything where you really have either an object graph in your domain anyway, or where you have many relations and you would need to find links and something like that. So it can be many applications with the web, right? Like we linking pages and you can link this. Or if you say you need really to select based on criteria that you can define in such a graph. Maybe
some public service used GraphQL?
Directly none, or no projects that I can share. I know it is used in a lot of actually public services, and from something like government, where they think about a city or matching some information. You can think of something like maps, like Google Maps or Yandex Maps, where you can combine these and show them in a graph.
And one more question from Artyom. If something went wrong with a query, basically it's literal.
Yes.
And could you make some mistake, and how we can see it in runtime?
Oh, yes. So in the runtime, you will see it as an exception, very much like you would see in SQL. If you have a SQL exception, it's the same. How I would do it in development is always I would try my queries in the browser and see if they are correct, and then translate them to Java. But what is also nice, sometimes I have like copy and paste error because of these like dollar signs that you need to escape, and then I just run it in dev mode. And if there is a mistake, I just quickly fix it, and it's very fast. You saw the round trip time; it's quickly to do with Quarkus, and that's how I usually do it. And then of course try all the queries so that you know that the query itself works. Yes.
Okay, thank you.
Thank you. On top of what you said about public usages of graph databases, I wanted to share that almost any cloud provider like Amazon, Microsoft, and so on use graph databases, one of them inside, because they need to build networks of their clients, and they need to optimize something on these graphs. So yeah, if you are using Google or AWS or any other cloud, most probably they use it. Also, I have a question to you. I know about such language called Gremlin. It's a language for querying graph databases. It's not either, right? Neo4j doesn't make use of Gremlin.
That's a good question. If it can use it, like out of the box, it uses Cypher. I don't think that there's a support. Maybe there's a plugin for it. That's nothing I know. But usually you would use the Cypher language.
How do you think? What is the? How should we choose between object databases and graph databases? Like sometimes we can save the same graph of objects in ObjectDB, like OrientDB or something like that. What do you think about that?
That's a very good question. I would focus on the querying side, like how many queries and how many complex queries you have. If you say what you write, what you would write in SQL or in a relational database becomes very, very complex. On the reading side, then it might make sense. But at the same time, so I mainly see this for the reading side. Like for the storing side, maybe not so much. So where you say if you have a lot of savings, then saving data, then maybe not that much. But what I can recommend just to try it out is like even before you implement or starting picking something, just on a whiteboard, try to draw or try to write in pseudocode how it would look like. And especially all the queries, especially in SQL, if you see it becomes very, very complex. And in Cypher language, it's like 2 lines. I had such examples. Then I would say it might make more and more sense. But of course, you have to look at the overall picture. Right, because it's not just these queries; it's a lot of your data, and then if it's a good trade-off.
Usually in Gremlin language, there are some fancy functions like find me the shortest way from this node to this node. Is there something like this in Cypher?
Yes, not in Cypher per se, but there are some plugins and some extensions that you can use for Neo4j, and a lot of them are shipped by Neo4j already, and you can just use them with your typical graph algorithms that you had to learn in university, and all of these things are supported, like shortest path, and then you can use them or build something on top of it.
For our audience to understand, the basic example of shortest path on graph with coffee is like, what if I like fruity coffee and at the same time I love chocolate coffee, but there is no one bean with both tastes. The shortest path will show me two beans potentially, mixing which will give me some such combination of flavors, right?
That's a very nice example, yeah.
Yeah, I love coffee. Thank you very much. Thank you very much, Sebastian. Thank you very much, folks. Thank you for being with us. And see you soon. Bye-bye.
Bye-bye.